So, do you, what do you think? Viability, if you encourage, discourage. I'm not saying that you have to do the PCR. You can turn down also. We as an interventionist, we can turn down cases also, right?
Echo finding, symptom, if it is symptom guided ischemia, we think that this lesion produces symptom, so no question of viability. If there is any echo finding suggests there is no viability, then we go for MPI or other paid or respective. And in case of total occlusion, we give more emphasis than partial occlusion.
Slide please. Discussion is going on, so he can get more 5 minutes.
So if you plan to do the procedure, what will be your, so we thought that the viability uptake is there in the anterior wall, the inferior wall, CTO, we did not go for it. So we thought that we should target for the left vein going into the LAD and then CERT. So this was the report of the, I encouraged my fellows to see the viability scan themselves and try to understand the viability, right? So we all, for the sake of time, we wanted to check that this is the view, right? So how you go for this case, if you want to go. So we thought there is calcified lesion in the prox LAD, ostial LAD, the left main and into the circumflex is also tight. So if you want to decide to go for this, Ashok, what do you think? How you will go?
So for the left, there is no collateral to the right. So right is CTO, impacted. So definitively we will try to left vein to LAD because LAD ostium is most likely the culprit lesion here. LCS ostium there is minor disease, but I think that may be done as a provisional if needed.
So what we did, we went from groin and we did the.
Sudhirasan, I like to do IVAS to see the ostial LAD whether it is heavily calcified and calcification is more than 180 degree. Then I want to do blood modification and then go for.
So I thought that the ostial LAD is calcified. So I did not want to do IVAS. Fellow wanted to do IVAS. IVAS doesn't go. And then CERT, I said, you want to do the CERT? Then do the CERT. And then CERT is calcified 360 degree arc. So I said, both are calcified. So we are a rota standby, but I tried the shockwave for the ostial LAD and then the LAD also. But I did, the balloon doesn't go, so we did like a wood baking for the INUS, and happily it went, and then we got this in. But the question is, after that vessel preparation, what is next? We did the blood modification.
Yes.
Of course, the Ramesh mentioned about hemodynamics. The EDB was about 40. We are in Bella, and then as we are doing balloon inflation, you can see the cardiac output going down, and the mean arterial pressure going down. But after the blood modification, we thought that we'll have to commit for two-stage strategy. So we did the CERT, left vein, then tap, LAD, and then it was fine. So I think this shows that the complexity of the cases and then deciding about this, about what strategy we take. But it takes a whole village to actually decide on how we tackle this kind of complex cases. It's not just the operator experience, which is of course needed, the cath lab experience, the ICU team, and more importantly, I can't tell you how important it is to bring the family in the same page. This is very, very important. Thank you.
a very good discussion already there, so we are not asking for questions. Now may I request our next speaker, Dr. Dhiman Morik. He will give talk on clinical tools for a complex PCI. Dr. Dhiman Morik.
Respected teachers, colleagues and friends, I'm very much thankful to this Sky organizer, especially Professor Golamazon, for giving me the opportunity to present here. Regarding presentation, nowadays it is very much tough preparing the slide, and the slides are not moving outside and inside. It's a very horrible thing. So with this, I apologize if my slide does not move. The previous all presentations are dealing complex PCI. Now about some basics of PCI, about guide wires. I have no, this is my disclosure. Guide wires are mainly of four components: core, wire tip, body, and coating system. The guide wires are mainly of stainless steel or nitinol material. The guide wires which are of stainless steel are easier to taut, more rigid, and better delivery device. And the nitinol structures are more flexibility with kink resistance. The guide wires may be large in diameter. The large diameter may straighten the vessel and improve in torque. So these are the where you want to use a device or other support, you can use a large guide wire, large diameter guide wire. Soft guide wires are easily flexible and with high trackability in tortuous segments. These are the this is a core tip. This is the tip of the guide wire, which is of large tapering. It commonly entered into the angulated vessel easier and improved in tacking. The short tip guide wire are short in distances and they have a tendency to prolapse. And now the important thing of the guide wires is the hydrophilic or hydrophobic. Hydrophilic guide wire becomes a gel when it comes in contact with the wet surface, and then the friction, surface friction and increase in wetness and slipperiness. And there easily moves into the surface and unintentionally into the false lumen, giving rise to subintimal spaces and giving rise to dissection and perforation. So hydrophilic wire should be manipulated with care. And the hydrophobic wires works like coated surface, and then it enhances the tactile feedback, but decreases slipperiness of the guide wire. Lubricity is the tactile slippery character of the guide wire. Construction that enhances movement of the guide wire through vasculature and across the tight occlusion. These where the lubricity is increased, when there is no coating, it is less lubricity, and with hydrophobic wire, mild to moderate, with hydrophilic coating and highest lubricity with polymer cover with hydrophilic. These are the different guide wires available in the market. These are the CTO guide wires. Tactile feedback to an operator is the tactile sensation on the proximal part of the guide wire. While you are rotating the guide wire with a torque, that the physician that tells that whether the distal end of the guider, what is it doing, whether the pushability, crossability or the friction of the movement. Trackability is the ability of the guide wire to navigate the anatomy of a vasculature system. The tip of the guide wire, or whether it is hard guide wire strip, 3 gram is the highest tip load, intermediate guide wire at 1 to 3 gram of tip, floppy guide wire at less than 1 gram tip load. The guide wires that supports the devices very strongly. They are the thickness of the core material and is dominant source of support properties. Okay, my slide is moving. This is the case where there is a type A lesion in the proximal LED, and it was crossed with the run-through floppy wire and giving a drug-eluting stent, and this is the final result of the CSA. And so in this patient, no PCI is simple, but this is a simple lesion according to all. Then workhorse wire may be used. Workhorse wire are atraumatic acoustic, good trackability with favorable trackability. For treatment of a simple, short, concentric lesions in the presence of straightforward anatomy, the drop priority attributed required the wire to be safety. Recommended guide wires are run-through floppy wire, BMW, choice floppy wire or Sion 2. This is my second case is a 55 years male with an STMI, and he has a primary PCI was done. RCA was completely occluded at his proximal part. It is crossed with a run-through floppy wire. Regarding tracking, it was tortuous. After the wire is navigated, it becomes straight. So suction was done. And 3.5, 30 millimeter drag instant given, and it is the final result. So in the tortuous anatomy, polymer or hydrochloric wire with soft tip can be used. In this severe tortuosity, the emphasis needs to be placed on the flexibility, lubricity, and excellent trackability. Recommended guide wires are whispered, BMW, choice floppy wire, and maybe pilot 50 may be taken. This is a third case where there is a Madina 111 bifurcating lesion in the LED and diagonal. The LED was crossed easily with an run-through floppy wire, but the wiring of the diagonal was very difficult. We had a support with a microcatheter and a hydrophilic floppy wire. Hydrophilic catheter was taken, and it was then changed with a run-through floppy wire. And this was done at DK crash. I don't want to see that DK crash here, but I want to see, when there is the recrossing of the first recrossing of the recrossing of the diagonal to the stand start, you can take, this was a run-through floppy wire going, it was an end wire. End wire, to me, for the fellows for the newcomer, you can use an end wire everywhere in case of recrossing, but it is very difficult in our country. So run-through floppy wire going. If run-through floppy wire is not going, then you can have pilot 50 or other filter XT wire in this recrossing. First casing, I don't want to see this. And again, the recrossing of the rewire of the diagonal and the last time, second time. And this was also should be run through floppy wire. So final kissing, and this was the final result. This was the final result. So selection of the wires in bifurcation, the guider selection is not only needs a fine and floppy slippery wire with excellent trackability, but also to meet this A slightly stronger tip upload wire may be used here. BMW, Whisper, Choice or Pilot 50 may be used. Occasionally, in most aggressive wire such as Pilot 150 or Miracle Cross 3 may be needed to cross the stars of the bifurcating stand in order to enter the side branch. So, in case of acute thrombotic occlusion in STMI, recommended guide wires may be BMW, Ramsar and Choice. Subacute chronic occlusion, we need to consider other wires with a stiffer tip and high tip load that can successfully facilitate the crossing. These are the Fielder XT wire, Sion Black and Pilot 150. This is a CTO case there is a CTO